Hey guys. Okay, so math today is on coordinates, and what looks fairly easy sometimes is not as easy as it looks. And so I wanted to make sure, first of all, that that was working. Sorry. I wanted to go through just a little bit of that with you just to see what you remember on coordinates. And looking at Class Dojo, the pages that we posted are 26 and 27, and I'm not sure if that's what was printed as well or not. I feel like there's an error in that somewhere, and I apologize ahead of time for that because it looks like it should have been 25, 26, and 27. If you don't have page 25, that's okay. I'm going to start with it just for a minute so that you can kind of see where we are. And then we'll move on to 26 and 27, which hopefully everybody has. Next week's packets are going to be pre-made, much more organized. They should be coming in the mail to you this week, and it should be a lot easier to get through them. So I apologize if there's any confusion this week. But right now, coordinates, when we start with page, it actually started back on 24. Let me just show you some things with coordinates. It starts out really easy. And here it just says, okay, there's a shape on the number line, and there's a bunch of shapes, and it asks, well, what point is that on the number line? So for instance, if we look at shape A, it looks like an X, and so we find the X, and it's on what point? It's on 3, right? So that's super easy. So we would just write in 3. All right. So then let's jump down to one that's a little bit more difficult. If we look at B, it's looking for the star. So can you tell where the star is on this number line? Well, not too bad, but we're looking at these numbers here as our whole jumps, right? We have one whole jump, two whole jumps, etc. So then the star is not one whole, right? The star is right here, and it's not at one hole. So now we need to look at, okay, if that's the case, and we're looking at a part of a hole, how many pieces make a hole? So we have 1, 2, 3. How many pieces actually make the hole? 3, right? And where is the star located? So we know that the whole, this is a fraction, right? So 3 pieces make the whole. Where is the star located? At 0.12. So the star is located at 2/3. Does that make sense to everybody? So then if we jump a little bit and we say, all right, in that case, I need to find point, letter C says I'm finding the circle, right? So everybody see the circle? Okay, so we know that there are whole, and so right now we have 1 whole, and then we have 2 whole. Does the circle go all the way to 3 whole? No, so we know it's only 2 whole, but then there's still a fraction, there's still a part. And we know that all of these wholes are made up of 1, 2, 3 parts. But how many parts is the circle at? The circle is at our first jump, right? So it's only 1 part out of 3. So the circle is at 2 whole and 1/3. And I just totally drew that on the wrong place. You know that that actually goes over here, right? Miss Kelly and drawing on the computer. My fault. I'm so sorry about that. So let me fix that real quick here. Maybe. Okay. So knowing that, we know that this is really 2 1/3 over here on C. Okay. So you should be able to do D. You can see how many whole and then how many parts of the whole to do D if you happen to have that page. If not, think about it right now. Think about what is it and think about what would you write. Okay. All right, on the next part of our problems, and these are just kind of jumping around, and I don't know what just happened to our computer screen. Like the whole screen just jumped. That's pretty weird, huh? Let's jump down, and this happens to be on page 25. Don't know if you have page 25 or not, but I'm going to do a model. You can do this on a piece of paper or whatever you need to practice with, okay? And so here we have a number line, and it says we have to plot the point. It didn't give us the point on the number line. We have to figure out where it goes, all right? So plot A, so we're plotting the letter A so that its distance from the origin is 2. When we're talking about coordinates, the origin is always our starting part. It's where it originates, okay, where it originally came from. So origin is a really important number. And when we're talking about coordinates, our origin is always going to be our 0 point. What is the origin? The 0 point, okay? So we need to plot A so that its distance from the origin is 2. Well, that's not too bad because it tells us that this distance from the origin right here is 3. So we're working in whole numbers now. So where would 2 be? If that's 3, this is 1, and this is 2, right? So to plot a point, we put our point on the spot and we label it A because it said that's A, point A. Okay? So then if we look at B and we're plotting our point, it says plot R so that the distance from the origin is 5/2. Well, we know our origin is our what point? 0, right? Okay, 5/2. Is that proper or improper? Absolutely, that is improper, right? So we're going to make that into a proper fraction. How do we do that? We have to divide. So you can do it in your head. If you can't do it in your head, think about a division equation. How many times does 2 go into 5 without going over? 2 times. And 2 times 2 is 4, so we used up 4, and what's left? 1. But remember, we're talking about fractions, and it can't be a remainder, so it's 2 and 1 left over out of 2 that we started with, 2 and 1/2. So we need to plot a point that is 2 and 1/2. But in here, when it says 5/2, well, it happens to have them all halves anyway, so that's super easy. And they made it actually easier than I thought they would. Okay, so if this is 1/2, 2 halves, and then it tells us this is 3 halves, where would 4 halves be? Right? 4 halves would be our next one, right? 4 halves, and then we would have 5 halves, right? So 5 halves would be right here. This is 4 halves, right? That's 5 halves. And so this is point R, it says, so we have to label it with an R, okay? So this on C, it's very much the same, except look at that. The 0 seems to be on a different side. So we're counting 35 and then we're counting to 50. Well, 0 can't be way over on the other side of 50. It had to start down here, right? Okay, so this must be our origin point. And we have to plot L so that the distance from the origin is 20. Okay, so I have to figure out what are they counting by here? How in the world can I get there from that? All right, so I know that I'm going to find out what is the difference between 50 and 35. Okay, and 50 minus 35, what do you get? Oh, you get 15, right? So that means that Miss Kelly is going to mess you up with the origin right now is what that means. Okay, so I have to go, the distance from here to here is 15. If the distance between those two is 15, how much is each jump? Well, it's a whole 15 divided into 3 pieces, right? So I have 5, 10, 15. So each one has to be 5. We're counting backwards, okay? So ignore this for a minute because they didn't actually start with a 0 on there. That's my fault, okay? And we have to get to what number? 20, right? So we're counting backwards. So we're on 35. Count backwards 5. What do you get? 30. What comes next? 25. What comes next? 20, right? So when it says plot L so that the distance from the origin is 20, okay? So right here would be point L. That means our origin actually is way over here somewhere with our 0, okay? But they didn't give it to us. And so I didn't mean to confuse you with that part. I'm sorry about that. But does that make sense? Because we're seeing what is the difference. So we have to figure out how much did they give us between each number. That's why they gave us the 50 and the 35. So we could count backwards. Let's take a look at D for a minute. D says plot a point T so that its distance from the origin is 2/3 more than that of S. Ooh, okay. So here's S, right? And it gave us some whole numbers. It says, okay, so here's 4 and here's 5. And then right here, it says this is 4 and what? 1/3. So what's the difference between this point and this point? How much is the difference? If we do 4 and 1/3 minus 4, how much do we get? We get 1/3. So now it's saying we need 2/3 more than S. Okay, so we know S is right here. There's where they plotted it. And we need 2/3. Well, I know 1/3 equals how many pieces? this is kind of weird. 1/3 equals 2 pieces or 2 jumps. 1, 2. That's 1/3, right? So in order to do this, I need 2/3 more. So if I jump, 1/3 would be 2 pieces, right? 1, 2. This is 1/3 from here to here. Do we only need 1/3? No, we need 2/3, right? So we have to do it again. But how many pieces do we need in a third? We need 2, right? So you have to do it again. So this is another third. And 1/3 plus 1/3 equals 2/3, right? So we're going to plot a point that would be 2/3 more than S. And what do they tell us to call that point? Point T, okay? All right, so hopefully that is helping you a little bit. If you truly only have pages 26 and 27, we're going to run into a problem because 26 uses a number line that is on the bottom of page 25. So hopefully you don't really have those pages. And I'm so sorry if that's the case. If that is the case, you're going to need a number line that looks like this, okay? So draw it out on a piece of paper, and maybe that will help. You have from 0 to 6. The 0 starts over here. We're calling this line G, okay? And it has how many sections in each hole? Let's count. 1, 2, 3, 4. So there are 4 pieces in each hole, all right? So then it asks you to plot some points, and A, B, and C are on the bottom of page 25, right? So plot point A at 3/4. Well, we know that there are 4 pieces, so we have to just count 3 of them, but we're starting from 0 over here, right? So we go 1/4, 2/4, 3/4, and that tells us that point A is at 3/4, okay? Then label a point that lies at 4.5 as B. Well, think about your whole numbers, right? Here's 1. Oops, I just crossed it out instead of, didn't mean to do that. Silly, silly. 2, 3, 4, and I have to think about 4.5, and where would that go? Then C says label point C, whose distance from 0 is 5 more than that of A. So from 0, the distance is 5 more than that of A. So think about where that would go, right? 5 whole more. So when I'm thinking about a whole, how many pieces are making up a whole? 4, right? So if I'm thinking about a whole, let's change our color here. I know that 1 whole would be 1, 2, 3, 4, right? But I need 5 whole more. So you have to count 4 more times, right? You have to have 5 whole. So this is 1 whole. Where would 5 whole more than A end up? Okay. Then you keep doing that, and on the rest of the page, it tells you, okay, so let's plot the rest of these, okay, and what is the coordinate, all right? When you get down to the bottom, it's got a couple of word problems here that you could work out. It's got a number line. It gives you 0 to 12, but does it count by ones? No, it counts by twos. It's skip counting, right? So then you need to figure out, so Park says Lennox's number line is wrong because the numbers should always increase from left to right. So is that true? Do the numbers always have to go from left to right on a number line? You need to explain why, okay? If you have page 28, 28 gives you this number line, and it has you plotting the points, okay? Plot point C so that it's a distance from the origin, from its origin is 1, okay? So use the number line L to show these questions. Plot point E so that it's 4/5 closer to the origin than C. And plot a point at the midpoint of C and E and label it H. So you have to plot C and E and then find something that goes in the middle. Okay, so those are the questions for today. I know that that's a little confusing. If you are too confused, or if we don't have the same pages lined up, go on to Zearn today if you can. Just practice on Zearn. I will set it to some number lines and see how you do with those, okay? So if you have questions for me, call me or message me on Dojo. Otherwise, have a great day, and I will give you another instructional video tomorrow. Love you guys. Bye.